All right, all right. Going to do some problems from section 6.3. Going to do the odds. I probably should have opened up my book to the right page. Oh, I think I got it. Okay, so here we go. Says that you're going to do numbers 1 through 35, x7. I guess that means we don't have to do number 7. Well, that is what it means because I'm the person who wrote that. So let's get started. Evaluate the integrals using the indicated substitutions. So these are like problems with training wheels here, where they're telling us what to use for the substitution. In the real world, the so-called real world, you don't get this. You got to figure it out. But this is like the, from the notes, this is like the chain rule backwards. So what you're looking for here is the what's inside. And, sometimes it takes a little finessing to get it right, but usually you just look for like, well, it's like an inside thing. And here, if the u is x squared plus 1, then du dx would be 2x, and we move the dx up there, and you can see, so there's the 2x dx. So that looks good. So that means when I rewrite this, the 2x dx, that just turns into du, and then this is u to the 23rd. And then that's easy power rule backwards. That's just u to the 24th over 24 plus c. Forget that plus c. We're finding these general antiderivatives, because when I take the derivative of this, if that was just like plus 17 or whatever, it would go away. So that could be anything. Then the last step is to just go ahead and put that back. And that's all there is to it. All right, let's start cruising now. So I've got cosine of x, I'm going to write it like this, cubed times sine x dx. We're going to use u, probably cosine x, right? That looks like that's the inside thing. So du is equal to negative sine x dx. So I've got the sine x dx, and I need a negative. So the way I'm going to do this, there's different ways, different people going to deal with this. I'm going to go ahead and put a negative sign on the inside to go with this. And then if I put a negative sign here, I need another one on the outside, because negative times negative is positive. And that's the same as the original thing. So that one's still there. And then on the inside, I've got u cubed, and then negative sine x dx, that's du. So that's negative u to the 4th over 4 plus c, which is negative cosine of x to the 4th over 4 plus c. And if you want, every once in a while, you can just go ahead and test one of these to see if when you take the derivative of this, do you actually get the original thing. And you do. You should. You better. All right. So here, I don't really like that 1 over square root of x. I'm going to write that as x to the negative 1/2. And then I'm going to write this as sine of x to the 1/2. And they're saying that u should be equal to x to the 1/2. So du is equal to 1/2 x to the negative 1/2 dx. Well, there's my x to the negative 1/2, but I need a 1/2 in here. So if I need a 1/2 in here, then I need a 2 on the outside, because 2 times 1/2 is 1, and that's the same as the original. So I've got 2, and then 1/2 sine. So if I did that right, 1/2 x to the negative 1/2. Forgot my dx. Going too fast. That all turns into the du, and then sine of u, and then the antiderivative of that is 2. The antiderivative of sine u is actually negative cosine u, plus c. That's negative cosine of x to the negative, x to the positive 1/2. That's my u plus c. D All right, and u is equal to, that looks like the what's inside, 4x squared. They're telling us here, but you would have figured that out, right? You would have figured that out. du is 8x dx. Now, what do you do in a situation like this? Well, you could say, well, I would like this to be an 8, so I'm going to multiply by 8/3 and then 3/8 on the outside. That's fine. Or you could just move the 3 to the outside. You could put that 3 out here, and then you say, oh, I need an 8 in here, so I need to multiply by 1/8 here. Either way, you're going to get the 3/8 on the outside, however you deal with that. So 3/8, and then I've got 8x dx, it's my du, and then 1 over the square root of u, which is u to the negative 1/2. That's more calculus friendly there. So that's 3/8, and then let's see, I'm going to do this. Add 1 to the exponent, u to the 1/2, and then divide by the new exponent. So dividing by 1/2 is the same as multiplying by 2. So, and then don't forget the plus c. And so that's, what do we have? 3/4 u to the 1/2. That's 4x squared plus 5 to the 1/2 plus c. Try taking the derivative of that. See if you get the original thing. All right, number 3. More training wheels. So what's the derivative of cotangent? The derivative of cotangent is negative cosecant squared. So there's that. And so this one was trickier. If you're thinking about like looking for that what's inside, there wasn't really anything inside about that. You just kind of have to think about what's the derivative of what with trig functions and how you could get this to work. Now I'm going to need a negative sign in there, so I'm going to put one on the outside also. Oh. This my u, and this my du. So that's minus the antiderivative of u is u squared over 2. So minus u is, that's cotangent squared x over 2 plus c. That was A. B. Alright, so if the u is the inside thing here, 1 plus sine t, the derivative of that, derivative of 1 is 0, derivative of sine is cosine t dt, and I've got that right there, all good, no adjustments necessary. So that's the same as u to the 9th du, and antiderivative of that is u to the 10th over 10 plus c, so that's 1 plus sine t to the 10th over 10 plus c. How about cosine of 2x dx? So u is equal to 2x, and du would be 2 dx. So I need a 2 in here, which means I need a 1/2 on the outside. So that turns into 1/2, and then I've got my 2 dx and cosine u. So cosine u du, and and antiderivative of cosine is sine, and the u is 2x. So if you're looking at, if you're thinking about the chain rule, if the only thing that's going on with your what's inside, if it's just like a linear factor of x, linear factor of x means it's of the form ax plus b, right? So if it's a linear factor of x, then all that's going to happen is instead of like multiplying by the derivative of what's inside, you're just going to divide by the derivative of what's inside. Now, if there's other stuff going on with the x, then it's more complicated, like all this stuff. But if the only thing that's going on is just it's a constant times x to the first power, and you could have like a plus b or whatever, then you're just going to end up dividing by that. You can write out a u substitution for that, but it's going to get kind of old, I think, when you keep doing that and you keep getting the same kind of answer. So hopefully you'll pick up on that pattern and get comfortable with that. All right, last one of this little set here. If u is x squared, then du is 2x dx. Got the x dx, but I need a 2 there, so I need a 1/2 on the outside to balance that. And let's see, so I've got 1/2, and then the 2x dx, that's all my u. And then if u is x squared, so that's secant squared of u du. And so what's the antiderivative of secant squared? Oh, it's tangent, right? Because derivative of tangent is secant squared. You just have to know those. So that's tangent u plus c. And then finally, that's going to be tangent of x squared. Right? Great. Number 5. Aren't these four-part problems great? So let us see what's happening here. We've got dx. So when the dx is on top of a fraction, I've had students in the past who kind of don't like that. I'm not the biggest fan either. You could just move the dx off to the side and put a 1 up there if that makes you a little bit happier. So u is equal to natural log x, so du, the derivative of natural log, is 1 over x dx. So I've got the 1 over x dx, and after the 1 over x dx is gone, then it looks like I have a natural log on the bottom, so that's 1 over u du, after I swap everything out, right? There's the u there, and there's the du is 1 over x dx. So what's the antiderivative of 1 over u? Well, that's natural log u. Technically, you should put those absolute value signs. I'm not going to get too fussy at you about that. And then natural log of u is natural log, so it's the natural log of the natural log plus c. Take the derivative of it, just for fun. See if you get back to the original. Let's see, b. Now this is the thing that I told you. You can set up the u substitution and do all that, but I'm just going to remind you that if the only thing that's going on with the x is that it's a linear multiple of x, like -5, instead of doing like chain rule times the derivative of what's inside, we're going to do divided by the derivative of what's inside. And if you think about how the chain rule would work here to get you back to there, it should be pretty clear what's going on there, I think. So sine 3 theta 1 plus cosine 3 theta d theta. And my u is 1 plus cosine 3 theta, so du is equal to -3 sine 3 theta Okay, doing okay here, but I need that -3, so I have the whole thing. So if I have a -3 here, I'm going to need a -1/3 on the outside. So -1/3 times the integral, looks like I'm going to have this whole thing get swallowed up by the du, and then I've got 1 over this, 1 over u. Okay, -1/3, antiderivative 1 over u is natural log absolute value of u. All right. D. Last little bit of this problem. So I've got e to the x over 1 plus e to the x. If you don't have a hint about what the u is, these ones can be kind of tricky to try to figure out. Things like this. Du, derivative of 1 is 0, and derivative of e to the x is just e to the x, and then we can see, aha, that is a good choice. So that looks like, got my du is this, and then 1 over u. So that's natural log absolute value u plus c. And if you're really paying attention, you don't need the absolute value signs in this one, because 1 plus e to the x can never be negative, so or 0. So we're okay without them there, but it's not wrong to have them there. Just a little redundant. All right. Finally, take off those training wheels. Give me one problem at a time. Jeez Louise. So, what are we doing here? Which numbers? 9 through, come on now, where did I put that? Oh, it's right in front of me, right there. To 35. All right, so number 9. Here we go. We've got 4x minus 3 to the 9th dx. So if the u was 4x minus 3, du is 4 dx. So I need a 4 in here, which means I need a 1/4 on the outside, which means it's 1/4 times the integral. There's my 4 dx, u to the 9th, u to the 10th over 10 plus c. So u to the 10th over 40 plus c. Maybe I should just flip to the right answer, the right page in the answer book here to make sure I'm not telling you anything bad. Let's see. All right. Number 11. Sine of 7x dx. This is one of those ones. The antiderivative of sine is negative cosine, and the only thing that's going on is a 7 times that x, so that's -1/7 cosine of 7x plus c. I'm not going to write those ones out. You can, since we're just learning this u substitution thing. Same thing with 13. I've got secant 4x tangent 4x. Now, that's if it was just secant x tangent x, the antiderivative of that is secant x. And the only thing different is that it's 4x's on the inside. Those are linear factors of x. So all I have to do is, instead of multiplying by the derivative of what's inside, we're going backwards, so we divide by the derivative of what's inside. Take the derivative of that, just to check, to make sure. Same thing with 15, e to the 2x, the derivative of e to the, if it was just e to the x, then the antiderivative is just e to the x. So is that, but now I got to divide by the derivative of what's inside. That only works if it's just a constant times x. Beware. All right, how about 17? What does that look like? Need a little inspiration here. What does that look like? So hopefully you're thinking to yourself, thought bubble, that reminds me of the derivative of sine inverse. Now I'm going to write that as 1 over the square root of 1 minus u squared. So here, I would like that to be u squared instead of 4x squared. So u squared is equal to 4x squared. If that's what u squared is, then u would have to be 2x, so du would have to be 2 dx. So I need a 2 in here, 1/2 on the outside, and that means I have 1 over 1 minus u squared, right? And that's how you do that. I think that when I wrote this here, yeah, I don't know why I wrote another du there. The extra thing I needed to write was the plus c. Oh, maybe it was off screen. You didn't see that terrible thing that I did. Okay. 19. Let's see, we have t times the square root of 7t squared plus 12. So that looks like a what's inside kind of thing. I mean, don't be afraid to just pick something and then be wrong. You know, the worst thing could happen is you have to go back and try something else. 14t dt, so I got the t there, I just need the 14, which means I need a 1 over 14 on the outside. So that's 14t dt, that's all packed up inside the du, and then I got u to the 1/2. So the antiderivative of that, u to the 1/2, add 1 to the exponent, that's u to the 3/2, and then divide by the new exponent, which is the same as multiplying by its reciprocal, plus c. So that looks like I'm going to have 1 over 21, u to the 3/2, plus c. Better check that one just to make sure. Yep. Number 21. How about this? So if you think that you're some kind of math hero, there's lots of us out there think that we're math heroes, then you might be thinking to yourself, you know what, I think I can do some of this stuff in my head. That's all fine, but you need to be able to write it out too when you need to communicate with other humans. So it looks like here I would need a -2 on the inside. So that means I don't really want that 6 there. So I would rather move that 6 to the outside, insert a -2 here, and then divide by -2 here. If you have some other way of kind of balancing that and getting to the same result, that's all fine. But that's how I kind of think about it. So 6 divided by -2, that's -3, and then I've got my -2 dx there, that's my du, and then I've got u to the -3. And then I'm going to add 1 to that exponent and divide by the new exponent. I've still got my -3 there. So that looks like I've got 3/2 u to the -2 plus c. 23. x cubed fourth to... All right. That looks like a what's inside there. So u is equal to 5x to the fourth plus 2, and du would be 20x cubed. So that looks good, except I need a 20 there. 1 over 20 on the outside. So that all gets packed up into the du, and then I've got 1 over u cubed, or u to the negative 3. So that's u to the add 1 to the exponent, divide by the new exponent. So looks like I have negative 1/40th times u to the negative 2. Check that. Yep. 25. E to the sine x times cosine x. Who comes up with this stuff anyway, huh? So if you're looking for like a what's inside, remember the exponent in the e to the whatever, that's kind of like the what's up there is kind of like the what's inside. So if I made u equal to sine x, then du is cosine x dx. And that looks good, because I've got that right there. So that turns into e to the u du. And antiderivative of e to the u is e to the u. So that's it, folks. 27. X squared is e to the negative 2x cubed dx. That's looking like a what's inside slash what's up there kind of situation. Negative 6x squared dx. So I got the x squared, I just need a negative 6 there, which means I need a negative 1/6 on the outside to keep the universe in balance. Negative 6x squared dx, that's all packed up into the du, and then I've got e to the u. Don't believe me? Take the derivative of that using your derivative rules properly. Let's see if you get back to the original problem there. All right. Number 29. Oh, this is a good one. Tricky. So this is one of those ones. I think, I keep saying every once in a while that the best way to use these videos is to have the video of me doing stuff all queued up nearby to you. And if you get stuck, then you can unpause me doing whatever problem it is you're working on. And as soon as you think you understand, and you got unstuck, as soon as you think you might be unstuck, then you can take over. Pause me. Hey, be quiet, McGrath. It's my turn. So this one's a little tricky. Geez, I mean, I'm a calculus teacher, I guess, so, I can kind of see a little bit because of experience. Here's the thing that's going to work. If u was equal to e to the x, now you might think, oh yeah, that's the u. That's actually not the u we're substituting for. So du would be equal to e to the x dx. Okay, so how are we trying to rewrite this? So the e to the x dx, that's my du. And then here, 1 plus e to the 2x. So e to the 2x is the same as e to the x squared. So that's 1 plus u squared. So you might want to pause there so that I'll wash over you. And then the College Board's favorite thing in the whole world, pretty sure, is the fact that the antiderivative of this is tangent inverse, and vice versa. The relationship between these two, they just love it. They can't get enough of it. I'm telling you. That's a good one right here. Take the derivative of that very carefully and see if you get back to this original. And if you didn't, well, then you messed up. All right, 31. We're getting there. So the sine of 5 over x over x squared dx. That looks like a what's inside, so I'll take my chances there. That's the same as 5x to the negative 1. So du would be negative 5x to the negative 2 dx, and that x squared on the bottom is the same as that. Need a negative 5, so got to balance that. So negative 1/5. All of this is the du, so it's just sine u du. If you pick right, really all gets sucked right back in there. Negative 1/2. Antiderivative of sine is negative cosine. I think we got 2 more left. Like the final countdown here. Uh, 33. Sorry, I wrote 2's there instead of 5's. Just fix that. Cosine of 3t to the 4th sine 3t dt. So how's about we make u equal to sine 3t, so du would be 3 cosine 3t dt. So, oh, what did I do? Sorry, I picked the wrong thing there. I meant to pick this. Let's fix that. Cosine, because this is the what's inside. Cosine 3t, and then the derivative would be negative 3 sine 3t. So I need a negative 3. Negative 1/3. Negative 1/3. Then negative 3 sine 3t dt. All of that is the du, and then I get u to the 4th. Antiderivative of u to the 4th is u to the 5th over 5. So it looks like I got negative 1/15 times u to the 5th plus c. Last one. X secant squared of x squared. That looks like the most inside kind of thing to me, so I'm just going to try that. 2x dx, of course, that's always a good sign when you get some version of a thing that's already sitting there, right? So 1/2 integral 2x dx, that's the du, and then that's secant squared of u, and the antiderivative of secant squared is tangent. Oops, don't want to write that anymore because I'm doing the calculus part. Tangent u plus c, and that is 1/2 tangent of x squared plus c. And that's it. I just want to show you something here in the whole world of memes that we live in. There's a funny calculus meme that's up here in this little collection. Some students, I think it was academic teamers, put this up on my wall one year on my birthday. And this is one of our favorites here. See that guy, Success Baby, had calculus exam. Didn't forget to add C, to put the little plus C on there. So now you get that joke. It turns out that baby that was being called Success Baby around the internet back when that was going around. You guys might have been small children. You might have been babies when that was happening. For all I know, it turns out the real story is he was sitting on the beach and he ate some sand. So it looks like he's doing like the fist pump thing, but in fact, he's got a fistful of sand and some sand in his mouth.